What's up, people? Great to see you. Hope you're doing good. We're about to get into it today on 2-2-2. Okay? So we're going to still be dealing with equations. They might look a little bit different than what we saw in 2-1, but pretty soon, once we get through another step, they might look similar. So anyway, we should be in our workbooks here. Mr. Noel, do you know what page we should be on?
Page 92 and 93.
92 and 93.
Yes?
Okay.
I'm pretty confident in that.
All right, so with that, here we go, guys. Whoa.
I was right. 92, 93, everybody.
All right, let's take a listen.
How do you use inverse operations to solve equations with variables on both sides? Think about this question during the lesson.
Both sides. That's awesome.
Jonah and Lizzie are both making smoothies. Their smoothies will have the same number of fluid ounces. Jonah uses 6 ounces of juice, and Lizzie uses 12 ounces. Jonah uses 4 containers of yogurt to make his smoothie.
Okay.
Lizzie uses 2 1/2 containers of yogurt to make her smoothie. How many ounces of yogurt, X, are in each container?
Who's to say?
One way we can solve this problem is to draw a bar diagram that represents the situation.
Yeah.
Then, we can use it to solve for X. The top bar will represent Jonah's smoothie, and the bottom bar will represent Lizzie's. The darker part of each bar represents the amount of yogurt. 4X for Jonah, and 2 1/2 X for Lizzie. The lighter part of each bar represents the amount of juice each of them used. 6 ounces of juice for Jonah, and 12 ounces for Lizzie. We need to divide the bars to compare the 2 smoothies.
Ooh.
Watch this.
Ooh.
The first column represents 2 1/2 X for both of them. The third column represents 6 ounces of juice for both of them. The second column represents the remaining part of each smoothie.
I wonder
For
how you
Jonah,
find that.
that's 1 1/2 X ounces of yogurt. For Lizzie, it's the other 6 ounces of her juice. Look more closely at the second column. You can think of 1 1/2 X as 3 copies of 1/2 X.
Whoa.
And we can also break Lizzie's bar into 3 equal sections of 2 ounces each. So 1/2 of X is 2 ounces. What's X? The diagram shows that X is equal to 4 ounces.
Okay.
Another way to solve this problem is to write an equation, and then use inverse operations to solve for X.
That's a better idea.
That's
How does the
what
bar
we want to
diagram
do.
help us set up the equation?
All right. So yeah, guys, don't pay attention to what they just did. Like, I didn't even follow that. Their 1/2 X is this, and and
I liked it.
Okay, yeah, of course you would. Guys, here's what we got. Remember, bar diagrams. Are the 2 bars the same length? Yes, they are. That means whatever is in those bars will be equal to each other, right? That's what when they're going to make their equation, that's what they're going to do. They're going to take Jonah's smoothie. They're going to set that equal to Lizzie's smoothie. So let's watch them do that. You guys ready for it?
Absolutely.
Okay.
The bar diagram helps show the relationship between the quantities. 4x plus 6 is equal to 2 1/2 X plus 12.
There we go.
Subtract 2 1/2 X from both sides of the equation.
Okay. So guys, if you look real closely here at this equation, why does this look different than last week's or yesterday's equations that we had?
I know.
Anybody know? Oh, this guy over here knows? What is it?
Well, there's a variable on both sides of the equal sign.
Ah, there we go. So guys, we've not seen, last week our variables were together, right? Combining like terms, they were together on the same side. Now they're on different sides.
We can still combine them, right?
We can still combine them, but we got to do some other stuff first.
We got to use some inverse stuff.
Yeah, so they say inverse operations. So they subtract that 2 1/2 X from this side, right? From both sides, right? That's how they're moving that term, that variable term over here.
Sweet.
Right? So guys, let's think about what's going to happen here, right? So they're going to get a variable. They're still going to have a 6 over here, but then a 12 over there. So I wonder what we're going to have to do with all that stuff.
I know.
Why should we subtract 2 1/2 X from both sides?
Opposite operations.
Yeah. And for right now, we're always going to take away the smaller of the two coefficients.
Yes.
That's right.
Yeah, guys, this will work the other way. What Mr. Noel's saying, hey, 2.5 smaller than 4, so we want to move that over here to the left. Let's be clear, we could move the 4 over here, but then we'd get a negative coefficient, and who likes negative numbers anyway?
Miss Maley.
Yeah, Schmaley, as I call her. She loves negative stuff.
We subtract 2 and 1/2 x from both sides to get the variable terms on one side of the equation.
Yep.
Notice that, since 4 is greater than 2 and 1/2, it makes sense to subtract 2 and 1/2 x from both sides.
That's right.
Now, we have only one variable term, and it has a positive coefficient.
Sweet.
Subtract 6 from both sides to get all of the constant terms on one side of the equation. Again, we have only one constant term left. Here's an equation that we definitely know how to solve.
Yep, we've seen these.
If you rewrite 1 and 1/2 as 3 halves,
Just divide by the
multiply
coefficient.
both sides by the multiplicative inverse.
Ah, you and your
2/3.
multiplicative.
So, this method also shows that x is equal to 4.
Nice.
Okay. So, guys, real quick. Again, we're not always going to multiply by the multiplicative inverse. Divide by the coefficient. That's what we've been saying all last week, all this week, okay? So we're going to divide by 1 and 1/2 or 3/2, whatever you want to put into your calculator. Let's go back to this step, right? We have to make sure that we move that this constant term 6 over with 12. We cannot move 12 over with 6 because then all the terms would be on one side of the equation. Remember, folks, that's not what we want. So if the variable's on this side, the number's got to move away from it. They've got to move to the other side. That's that whole isolate the variable thing we talked about. Okay, you ready to solve one on our own here?
Yep.
Dang right we are. Okay. Oh boy, we got all kinds of boxes here.
I like it.
Okay. Let's see what we got. We've got two classes we're talking about. Class A has a sunflower with a height of 8 centimeters. Okay, 8 centimeters tall. It's really big. Grows at a rate of 3.5 centimeters per week. Class B has a sunflower as well. They have a different height. Theirs is 10 centimeters, and it grows at 3.25 centimeters a week. After how many weeks are the sunflowers the same height? So we need you to start to realize which one of these terms is the variable term, is changing. Which one of these is the constant term, right? It's just there. It doesn't change at all. So if we look back at Class A, right, we're going to talk about sunflower height of 8 centimeters. Is that a constant term or a variable term? Grows at a rate of 3.5 centimeters a week. Again, think, is that constant or is that variable? Is that going to change? Okay. Hopefully we said 8 centimeters is the constant, 3.5 is the variable term, right? Now yes, good work. They're telling us what variable to use here. Typically we could use whatever we want, but they said let W be the number of weeks, okay? So let's do a little bit of this. All right, this is where our variable is going to go. So this is going to have to be 3.5 W plus 8. Right, and Class B, same structure, right? 3.25, right? That's their variable term. Their constant was 10, right? So theirs is a little bit taller. So we're going to make this 3.25. If you're a decimal person, guys, put decimals in there. I don't really care. Okay. All right, what did they do in the video? They moved the smaller coefficient. Guys, which number, right, or which variable term has a smaller coefficient?
3.25.
That's right. That's this one right here. So that one's going to move to the other side, right? So this one's got to move over here. Again, think opposite operations. If you're not sure, guys, you can always ask yourself this question. Is this 3.25 positive or negative? Positive, guys. So if we're going to do the opposite of that, we're thinking, oh, negative, or subtract it, okay? So that's what we're going to do. We're going to subtract 3.25 from both sides, minus 3.25. Sorry for my sloppy handwriting. Guys, 3.5 minus 3.25.
1/4.
Man, they don't know their fractions very well, Mr. Noel.
1/4.
All right, so we got 1/4 W plus 8 equals 10. Again, we didn't do anything with 8 or 10. They just stayed where they were.
That's right.
Now we're going to move our constant terms together. So ask yourself, should the 8 move over to the right, or should that 10 move over here to the left? That's right. We said isolate the variable. So that means 8 going to go over here. Opposite operations. We're adding 8, so let's go ahead and subtract 8. This one's a doozy, guys. What is 10 minus 8?
2.
All right, it's 2, folks. Okay.
Final answer? 2?
Final answer is not 2, Mr. Noel. We're not solved for W yet. We're solved for 1/4 of W, which is 2. To find out what 1W is, we're just going to divide by the coefficient of 1/4. So we're going to divide, right, by 1/4. Over here, we're going to divide by 1/4, and we get, that's right, we get the old snowman. That's our right answer here. That is the wrong answer when you're on hole number 8 and
Yeah.
you take a snowman down at the valley.
That's bad.
That's not a good score.
That's bad.
That's bad. But here we got W equals 8, all right?
What does that mean, Mr. Freaky?
Well, I think W is the number of weeks that we needed these plants to be growing for them to be equal to each other, right? Or Class A and Class B
So,
to have our plants at the same height.
huh. So after 8 weeks, they'd
After
be
8
exactly the
weeks.
same height?
They are exactly the same height.
That is cool.
That is cool.
Wow, that's great.
Good stuff. All right, any questions from you guys? I didn't think so. You guys ready for example deuce?
Yes.
Bam, here it comes.
I
Get
wonder what
excited.
it is.
I don't know. Hopefully more equations.
Ooh, yes, percents, everybody.
Oh boy.
Teresa earns a weekly salary of $925 and a 5% commission on her total sales.
Commission.
Ramon earns a weekly salary of $1,250 and a 3% commission on sales. What amount of sales, X, will result in each of them earning the same amount for the week?
Okay. So this is kind of like the plant problem we just saw, guys, right? We're going to figure out when are these two people earning the same amount of money. We have to understand, though, what is this whole 5% commission thing, okay? Here's what it is, guys. Here's a really easy example. Let's say Mr. Knoll gets paid 10% of however much he sells in golf balls, okay? So he goes out and he sells $100 worth of golf balls. He gets 10% of that.
$10.
Means he gets $10, okay? Now, they're also going to give him just a regular weekly salary because he's a nice guy, and they know he's going to sell a whole bunch of stuff anyway. So that, again, how does he make money? Well, he gets his salary, then he goes and sells golf balls, and we add those two amounts together, right? And that's how much in total he gets paid. This problem has the same structure to it, guys. Both Teresa and Ramon, they earn a weekly amount of money. That's their weekly salary. Think about variable term, constant term. Is that going to change? Is that not going to change? Okay? So they earn a weekly salary, then they get 5% on top of that, right? We add those two numbers together, add them together, boom, that's how much they make.
That's their total salary.
That is their total salary. Okay, so again, they're going to use some bar diagrams here. That's great. Wait a second. Where did this 0.05 come from and 0.03? What is that? Everybody see that over here?
Oh, 5%, Mr. Freaky, means out of 100.
Oh!
So to change
Oh,
5%
okay.
to a decimal,
Mm.
you would take 5 divided by 100.
Okay. So, yeah, guys, hopefully as we were talking about this problem, you figured out that, hey, the 925 and that 1,250, those are the constant terms, right? Those aren't changing, right? Every week they're getting that, regardless of how much or how little they sell. What changes, right, is their commission or how much they're going to sell, right? So that's why they're getting the variable, and we've changed percents to decimals because we really can't do anything with it. Again, guys, both bars are the same length, so set each bar equal to each other. That's what they're going to do here. Maybe. Go to the next page to solve the equation. I don't want to go to the next page. I want to solve it right here, but we will. So, guys, way down here. Thanks for making this so small, Pearson. Savas, okay? Shh, there it
Wait
is.
for it.
Oh, wait, hold
for
on.
it.
Hold on.
Wait for it.
We might be able to zoom in with the power of the pinch zoom. There it is. Okay, so guys, here's our equation. All right, so where did this come from? Remember, our two bars up here were the same length, right? Here's Therese, here's Ramon, right? We set those two bars equal to each other. Now it looks just like the equation we had on example 1. We're going to solve it with the same way, guys. So we're going to go ahead, we're going to bring the variables together. Move the smaller one, okay? So we should be moving that 0.03, We're going to subtract that from both sides, right? That's what they did here on their first step, right? They subtract that. There it is. Beautiful. Now we're left with this 0.02x plus 925 equals 1,250, right?
Now move the constant.
Right, now we're going to move our constants. Ask yourself, which one should they move? I know you guys see it, but you got to get in that habit. We're going to move this one over here, not because it's the smaller one, but because it's with our variable, and we can't solve an equation like that, right? Bam. So we're going to subtract that 925. Now we're left with 0.02x equals 325. Are we done?
No.
Not done. Divide by your coefficient. Okay? They do that. There you go. So this is how much each one of them has to sell in order for them to earn an equal amount or the same amount of money.
Wow.
It's good stuff.
We don't even have a try-it for that.
We don't have a try it. I'm sorry about that. I apologize. You guys want me to make up an equation?
We could do an additional example.
No, we don't need to do that. We're just going to go right to example number 3.
Coming up.
Here we go.
Boom.
Love it.
Kelsey withdraws $25 per week from her bank account.
Okay.
Each week, Chris deposits $15 of his allowance and $20 earned from dog walking each week into his bank account. After how many weeks will they have the same amount of money in the bank?
What's
Okay.
withdrawal mean?
Yeah. So guys, we have to understand what is a deposit, what is a withdrawal. If we don't know what these do to the amount of money we have, this problem becomes very frustrating, okay? So if we look here, we kind of get an idea. Withdrawal, negative 25 or minus 25. Withdrawal, minus 25. Withdrawal, minus 25. So withdrawal means the amount of money in your account is going down. It's decreasing, okay? Do we know how much money she had in her account to start with?
Yeah.
We did, right? If you were careful and you saw, right, you saw it right up here, right? $550, okay? So she starts with $550. Every week she takes out $25, right? Our buddy Chris down here started with some amount of money. And again, we keep depositing $35, $35, $35, right? So guys, deposits are just the opposite. We like deposits. We don't like withdrawals. Deposit means, hey, our number is going up, right? The amount of money in this account is going up, okay? All right, so let's see what they do. Are they going to give us a bar diagram? No. But you got to ask yourself, which is the constant term, which is the variable term, right? Well, the constant terms in each one of these guys are their beginning balances, right? Or how much money was there to start with. The variable term is the deposit, the withdrawal, okay? And that's why we see this here. So, what's her name? Kelsey? So Kelsey started at $550. She withdraws $25 every week, right? That's why they subtract this 25. Okay, again, X represents the number of weeks, right? Chris, right, a little bit different, right? Remember, he walks dogs and he does something else. I forget already.
I thought he was just walking dogs.
No, he walks dogs, he does something else, right? What does it say he does?
He gets 15.
An allowance, 15 allowance.
15 allowance.
Yeah, exactly.
My bad.
So allowance, walking dogs, right? Again, that's where he's going to deposit that money. He started with 10.
$10.
Okay? So again, here's our equation, right? What did they do over here, guys? They combine like terms. Remember, when the terms are on the same side of the equation, we don't do opposite operations. Some of you will fall into that 8th grade trap. We just do whatever the signs say. In this case, it's a positive 15x, and we're going to add 20x to it. That's why they came up with 35x here. Solve it in the same fashion, guys. Smaller variable, it's going to move. Okay? Negative 25 is smaller than positive 35. That's why they're going to add 25 to both sides. Add 25 to both sides. Okay? Now it looks like this. Okay? What are we going to do here? Again, my variable term is on the right-hand side. That makes no difference, right? In the previous 2 examples, it was on the left, but it doesn't matter, folks. What matters is that we move this 10, right, away from my variable and over here with that 550 through opposite operations. That's why we're subtracting it. All right? 60x equals 540. You guys know what to do here. Divide by the coefficient. We find x. Remember, x is the number of weeks. So it takes 9 weeks, right, for these two people to have the same amount of money. Okay?
Sweet.
All right. Then things really ramp up with some decimals here. You guys ready?
Yes.
I'm ready. Okay.
Looks like we got to combine some like terms, huh?
Yeah, if we look here, guys, we're going to go ahead and my very first step is going to be combine like terms on the left-hand side here. Okay? So I'm going to combine these. Everybody else, you just stay put. Look, I'm a big line drawer for my left and right side of my equations. So we're going to do that. 96 is going to stay put here. We're going to subtract these two. What is that, 7.7?
Absolutely.
Negative 7.7y equals 5.6y plus this 42.8. Okay? Ask yourself, which is the smaller variable? Is it 5.6? Is it negative 7.7? Whichever one's smaller is the one I want to move, right? That's this negative 7.7 here. So opposite operation. So we're subtracting it here. I would like to add it to both sides. Add 7.7y, okay? Guys, this is why we do this. Negative 7.7y plus 7.7, 0. It goes away.
Yes.
All I have left is this 96, okay? We're going to add these up. This is going to be
13 and 3/10, everybody.
Look, I was all over it. 13.3 plus 42.8. Okay? Okay. Variable on the right-hand side. So I don't have any choice. We have to move this guy right here. Yeah, the 42.8, right? It's got to move over here to the left, right? So this one's got to go over here. Again, opposite operation. We're adding 42.8. We are going to subtract 42.8. 42.8. It goes away here. 13.3y.
53 and
Yep.
2/10, everybody.
53.2. Okay? We're home free, guys. We should know how to solve these. Divide by your coefficient. So we're going to divide here by 13.3. Divide here by 13.3. And we get y equals, what is that, 4? Oh, look at that. Yeah, there we go. Not a very good y. Show your work. Circle your answer, guys.
That's a rectangle.
Yeah, that's fine too.
Oh.
Show your work, box your answer. That's fine too. Guys, why do we do that? Well, it helps Mr. Noel and I help you when things go wrong and you didn't maybe subtract or add where you should have. We can see all your steps and what you did, okay? Guys, hey, there's examples 1, 2, and 3, right? Again, variables are on both sides. We got constants on both sides. We're going to keep on going here with the fun with our key concepts, which will be on page, 95, I believe? Is that 95?
94.
94, something like that. Yeah, anyway, you guys will figure it out. We'll see you then.